Good morning, everybody. Welcome to Taster Fair 2022. And this event is actually hosted by the Biomedical Engineering program, Chinese University of Hong Kong. Now, me, a professor here, my name is Aaron Ho, and then I have two other professors who are also co-hosting this event. Professor Martin Mark, which is actually at the top of the screen, and then Professor Li Ting Duan. She's also co-hosting the event. Now, the Taster Fair is meant to be to give students an opportunity to have an early taste of what university lecture is like. So we try to actually give you a picture of how we conduct our lectures in university. It's very different from that of secondary school that you're used to. University is open education environment, so students can come in and go anytime they want. It is usually big classes. So today I'm going to do that for one time. Now I'm going to actually share the screen now. Okay, so right. So in front of you, you're going to see a PowerPoint file. I've actually shown you all the slides that I'm going to do. Now, you are already aware that today's topic is called COVID-19 and BME. So the aim of the lecture is to tell you something about relationship between the two. Now, in the university lecture, the professor, before he starts the lecture, he usually gives you an overview of what the lecture is all about. So I'm doing exactly that, to tell you that we have 18 slides of content to show, and it's covering the topic of COVID-19 and BME. Okay. So I'm going to do the presentation. Oops. It's well advanced. Right, so this is a start. I'm going to use a pen. So myself, Aaron Ho, it's in, you see my image, and then Professor Martin Mark, and then Professor Li Ting Duan. And within today's event, we also have two student ambassadors from year 3 and year 4. Patrick Se and Boris Leung. And Patrick is going to actually give us a 5-minute sharing speech after today's presentation. So this is the flow of today's event. The presentation has 3 parts. Okay, I'll first talk about the background and an update on COVID-19. The reason we choose COVID-19 is because it's so related to BME, and there is a lot of things that we can talk about. So I'm going to give you a sort of background knowledge, and then after that, Professor Duan is going to take over, and then I'll stop sharing, and then Professor Duan will actually start sharing, and she'll talk about what have changed in the past 26 months since the start of the pandemic, and how vaccines works. And then the final part will be what is going to be like when the pandemic is over, and what has the pandemic actually brought us in terms of technology improvement and technology opportunities and so on. And Professor Martin Mark is going to do that part. And finally, there will be sharing from our student ambassadors. And finally, there will be about 15 minutes of open forum that everybody participate, and you are welcome to use the chat room to type in your questions, or you can just switch on the microphone and ask us questions. So let me go to the introduction. Now, the COVID pandemic started in early 2020. When we had the first Taster Fair, we already picked up that topic. So we did some statistical search. Now, as scientists, as engineers, we are very sensitive to numbers. We always look at numbers because numbers don't lie. And here we are looking at numbers. So hopefully we can get some information from those numbers. So May 2020, at the sort of beginning phase of the pandemic, we only had just over 0.3 million of cases. And then a year after, we already had 3.4 million. And as of today, less than a year afterwards, 10 months afterwards, we already had, oh, I beg your pardon, I think I've got it wrong. We had 2.7 million at the start, and then 15 million last year, and then now 57 million. Okay, and then overall, the number of cases went from 5 to 166, and then to 472, and then the number of deaths also increases steadily. Now, if we actually look at the analysis of those numbers, in that time period, number of cases increased 91 times, okay? And then the death only increased by 18 times. Death rate dropped by 14% to 1%, okay? So those numbers have told us that, you know, something has changed over the course of the pandemic, okay? No signs of slowing down because the number of cases, if you can see, increased very sharply in recent months, okay? But the number of deaths dropped very sharply because of vaccines, because of mutation of the virus, okay? And but we still not in a position to predict what it's going to be like, an end date is going to be near or not, okay? So that's basically what has happened. What about Hong Kong? The situation in Hong Kong is quite dramatic because we've been holding up very nicely. You know, over the past 2 years, we didn't have any case at all. Everybody was happy because we've been taking all the measures to prevent the spread. And suddenly, in 1 month, okay, so February to March, just 1 month, okay, we have 10 times increase of number of cases. And then the total number of deaths increased by 16 times. Okay, so we had a very sharp increase of rates of infection. And we've been holding out very, very nicely. Of course, I mean, you can see that because we've been taking a lot of measures to prevent. But when things start to happen, it just like an explosion, it happens very rapidly. And in fact, we can see that it's actually very much sort of modeled by the exponential function. Okay, so the number of cases increase exponentially with time from a base number. When the base number increases, you just go up very dramatically. And secondly, in Hong Kong, the density of population is very high. We are amongst one of the highest in the world. And because of that, infection rate increases very dramatically. We have a very good rate of vaccination, and that also helped. And because of vaccination and because of very fast spread of diseases, and we can very quickly achieve herd immunity. The reason I say that is, in fact, if you notice, in fact, in the past 2 weeks, case numbers dropped also very dramatically. So the rate of increase is quick, but the rate of decrease is always quick too. And so it's a very dramatic situation, okay? And it's definitely explainable by statistics. And also the death rate is higher than what people expected, but there are questions we can ask because Hong Kong has an aging population. Hong Kong has a very high density of elderly homes. And don't forget, the case actually happens at a time when other parts of the world has gone through multiple waves of the infection. And so all the deadly variants already skewed the statistics. In other words, the recent lower death rate in other countries may have been related to the fact that you know, the ones that have been affected already affected long time ago. Okay. So finally, In 2003, Hong Kong had SARS. And from that, we learned a lot. We took a lot of measures to prevent COVID. But the situation is complicated. There are facts of life we can't change. That is, densely populated areas in Hong Kong. When you take the MTR, people are so close to each other, infection is unstoppable. And therefore, it sort of suddenly explodes. But when it explodes, it goes up fast and it dies away fast too. Okay, but still, we're not coming to the end, and there's no prediction of an end. But hopefully, things will be back to normal in the near future. Now, if you have any questions, I would like to invite you to actually type in your chat in the chat room so that we can answer your questions. And then here, we're going to explore what role does BME play. And I'm going to stop sharing, and I'm going to hand over to Professor Mark to continue.
Okay, so can everyone see my slides?
Oh, Professor Duan.
Yeah, so continue on Professor Ho's discussion. So next we're going to talk about what has changed due to the pandemic. So here is one image showing the student lives of BME department. So you can see we do have a diverse range of students from different backgrounds. And then we had a lot of this on-site events before 2020. So this is the international night we have. But suddenly heading to the 2020 and afterwards, and most of the courses we had are online, except for last semester. The fourth semester is still on site. Yeah, so and then I believe some of you are already adapted to the online teaching because most of the secondary or high school teaching are also switched to online. So it changed our life into a more online interactive mode. And not just our life and then our learning, teaching, but also it drives a great needs for the society to have a more intelligent and then more a digital way for disease treatment and disease diagnosis. So that gives a lot of innovation. So in health technologies, based on the software part, and then I believe you have seen many this kind of small biomedical devices that can help people to monitor the health conditions in real time. But not just the soft part, but also the high tech and the physical part, because the rise of the diseases, the COVID-19 diseases, and also the needs for those treatment in the pipeline of the treatment, the needs for those instruments are greatly increased, ranging from the ventilation, intubation, oxygenation, etc. So that gives us a wide range of opportunities, depends on which you wanna do the innovation in the field of biomedical engineering. You wanna do those new things in the soft part, or you wanna do new things in the physical part, instrumentation part. So that's a wide variety of choices, directions we can explore. And because of the big challenge arising from this COVID-19 situations, so we do have learned a lot of experiences from this big pandemic. And then I would say that one of the lessons, as also Professor Ho mentioned, is the vaccination. So here I'm going to spend the next few slides talking about the vaccination. So one of the very innovative thing emerging from the pandemic in BME, I would say, is the mRNA vaccine. So normally we have the protein-based or the antigen-based vaccines. That's the conventional way, but we have the mRNA vaccines. So what it does is we have these mRNA molecules, and it itself is not a antigen. It itself is not proteins, but it can make cells to produce proteins that mimic part of the antigen, so that it can activate our immune systems. So if we compare, let me just draw it here. So if we compare how the conventional vaccine work and how the mRNA vaccine work, is that mRNA vaccine start at the RNA level, and then it make antigens at the protein level, and then activate our immune systems. But the conventional way, we directly make the proteins and activate our immune systems. So this is the very drastic difference between the new vaccines. And then in the new vaccines, not just the RNA technology is the key, but also other biomedical technologies are needed. One key technology that determines the safety and also the efficacy of RNA is the liposomes. So liposome is a very interesting, I would say, a nanomaterials. It's composed of those lipid molecules, and then they wrap everything inside it and then form a spherical compartment. So RNA is inside it, and the liposome is outside it. And our RNA vaccines are wrapped in this way and then injected in our human body. So another thing I would like to say is through the COVID-19 situation, so more and more people recognize the power of the novel BME technologies is because since the COVID-19 started to emerge in 2020, and then just within 1 year, we have the mRNA, we have the vaccines. But I believe some of you took these vaccines already, or took the flu vaccines every year. But it usually takes tens of years for these conventional vaccines to be developed. But mRNA vaccine, just 1 year. So what is the key thing here? So what is the miracle step here? So this is because one of the key, I will just mention briefly, is that one of the key thing is the production. So because it's the mRNA, is the key molecules, is the key ingredient. So mRNA can be engineered and produced faster than those conventional proteins or microbes in the conventional vaccines. So that's why we can have such a successful vaccines in the short time, and then many people can get vaccinated. I think that will be the key in our fight against COVID-19 situations. And then that's how the novel biomedical engineering technologies play a critical role in this worldwide fight. Martin, is this slide your, are you going to take over from this slide?
Yes, or you can just finish the mRNA, I don't know. Probably I can take over according to the sequence. So yeah, thank you very much for Professor Duan, and also the introduction from Professor Ho. So now I'm going to share my screen. So everyone can see my screen now. So after you knowing about this microRNA technology and how fascinated this technology used to produce kind of proteins from RNA level, then to trigger an immune system to be a kind of vaccine. So today, this is just like a start, because actually the conference actually pushed the technology to move much faster than it should be. And then what we think about this opportunity okay, everyone's saying, okay, it's a bit sad, so we have this pandemic, but basically it's kind of opportunity because actually it drives the technology move much faster. So we are actually envisioning that, you know, what we have today, this microRNA vaccine technology could be useful to be a new treatment or vaccine for other disease or replacement of other, you know, traditional vaccine. Like Professor Don said, there's a lot of advantages of those microRNA vaccine. So it could be a kind of replacement for vaccine for infectious disease or cancer vaccines, or something related to this T-cell amplifying microRNA vaccine or microRNA encoded immunotherapy. The last two one is more like how to push our, you know, immune system to recognize something, you know, for our health and against certain kind of, antigens inside the body. And also, this technology could be useful for beyond what we have already as kind of vaccine, traditional vaccine. That's something that we don't have a vaccine yet, probably like autoimmune disease, allergens, inflammations, regenerative medicines. So basically this microRNA technology open up the opportunity to develop vaccine that we think we don't have it now, or we now think about we should have it. And so this is something that, as I say, is a threat for today, but actually it built up new healthcare system in the future. So it's opportunities. So next slide. Okay, wait a moment. We go to full screen mode. I think it's easier. So, but not talk about vaccine because actually, I think probably you know recently, we try to implement some kind of treatment and oral drugs for treatment of COVID-19 disease. So I mean, it's not only about prevention, but now we have a new treatment. So, well, actually, these are the two drugs produced by two companies. One's from Pfizer, one's from Merck, and they're already being introduced, you know, to some of the patient who suffer from COVID-19. So what bioengineering does is that, you know, it opens up new opportunities for us to, you know, to develop, to understand new mechanism on how this antiviral, how this viral being replicate themselves. And by understanding this mechanism, we can produce some drugs to stop the self-replication process of the viral. We also can introduce new rational drug design approach to make new drugs. Right now, you only see two drugs from the company, but we foresee in the future there will be more drugs being introduced. Also, we'll develop, it gives also opportunity for the engineer to think about a new oral drug formulation. But for sure, this is something just get started. The most important is that it will still perform long-term safety studies to knowing about how these drugs behave and probably enable us to produce better and more efficient drugs in the future. And in the past, people think about that, okay, if you got viral infection, stay home, you know, if you have severe syndrome, you go to hospital, ICU unit, but now it opened up a treatment for virus disease. COVID is just the start. So will it be a future solution for viral disease? It's also open up a new opportunities as well. So we talk about, it's a difficult time. So we know that everyone right now need to go out and to wear face masks, and all in sudden that face mask is being very popular and everyone need to wear face masks. I think at the beginning, everyone know about face masks only like, okay, people who work in hospital, they wear face masks. And in the SARS, people know about face mask, probably they know about the brand only from 3M, they know about N95. But nowadays, you know, so many face masks is being introduced. You know, you have the Korean standard, KF94, and you know, different style. This is the normal one this girl's wearing is from the hospital, but you see so many different designs, 3D folding. You know, this is something that actually this pandemic also brings opportunity to drive technology, because we are we are trying to develop new masks, engineering, trying to develop new masks that fit the scenario of the people who need them. Probably, you know, this 3D face mask produce a better comfortability. It fit better to the face. People think about how you actually wear the face mask. People think about it as leaking. So all these designs are part of the engineer or BME trying to researcher trying to push, and is also caused by the pandemics. It's actually improving all this protection equipment, not only for today but for the future. And the other part is, you know, this standardization consumable. You know, we have so many different kind of like sanitizing for washing hands and things like that. And also, some company already start to introduce some kind of home dispenser. I think that you saw it from the market, how you can actually spray this kind of aerosol to your clothes or bags after going back home. So these are consumable being designed to have a better standardization of our personal, for personal protection. And also personal protection garment, you saw that people were in the hospital or some kind of like blood or PCR test station and things like that. For sure, everyone now we are using apps. We need to have this software to on some shutdown we call in Cantonese, and we need to use it and to enter all these different places and so on and so forth. I mean, this is only about Hong Kong, but I know that some other countries they also implement this kind of software to get kind of a control or warning to the people who are exposed to a high risk area that they should be careful and they should be tested. And also this kind of body temperature scanning system and so on and so forth. Those are a lot of things we see this COVID-19 actually is a threat, but it's improving the entire system, healthcare system in the society that help us to face the future challenge. Because we know that COVID is COVID, but you know other disease will come, just a matter of time. So not only about prevention but diagnostics. So we see that actually now people doing a lot of PCR tests, but not only PCR tests, and but there's also company developing some kind of home-based PCR test already. I think you saw in advertisements that you can try to bring this test not only in the central laboratory, because some people don't want to kill for hours, and instead we know that it's insufficient. But then, you know, this kind of new home testing is something that is going to be developed. And also, right now, a lot of people doing this antibody antigen biosensor kits, we call the rapid test, or people call lateral flow test. This is something already also implemented, which is suitable for you know, high population screening, and is distributable. And so this is something also being pushed by the pandemics for new diagnostic system and things like that. And then at the and then for sure that some people, unfortunately, if you have all this prevention and vaccination, some people, unfortunately, they still infected by the COVID-19, and then we need treatment. So then we see that, you know, a lot of hospitals are being upgraded. So I mean that we need a new design on the hospital ward with negative pressure. So in the past, there's only very limited, and right now we see that actually they have more better designed for all these hospital ward to control the airflow. So to contain the not only to contain the patients, but also give protection to the hospital staff and nurses and doctors. So this is something that we see how this threat improving also the healthcare system and hospital facility as well. And also it provides a better oxygen breathing apparatus. And and to help the patient to recover. And also, as Professor Don already said, that most important is that it's accelerated development of new vaccines. And based on these microRNA technologies, So that, and also we saw that there's a new drugs already to treat virus disease, which is not exist in the past. So all these are kind of things that pushed by the pandemic, and actually what all these, not only from a biomedical engineer point of view, that we provide a new tools to support our front staff, like the nurses and the doctor, but also the society, all the citizens, like the personal protection equipment, to fight against these pandemics and disease. And so think about, okay, so hopefully this pandemic will be over in summer this year, but then we think about what will be next post-pandemic. So then with all this, we think, we will have more tools to monitor our healthcare surveillance. And then we'll have a widespread use of mobile telecommunication for continuous health monitoring. I think that already some people using this app, and probably it's also, we have this self-reporting system. I think that in the last couple of weeks or months, they introduced that you do your rapid test, you report your positive from the rapid test using this system, online. We also call this kind of telecommunication system as well. So this kind of self-reporting will be implemented in the future. We don't know, but we'll see how it's going to be advancing in the future. Also, like we said, that the price will drop for air filter fabrics. You see at the beginning how expensive is the face mask, and now you see that they have better design, better material, while the price is dropping. But it also depends on the demand. Sometimes we have the fifth wave all in sudden, and it goes up a little bit. But in general, the price is dropping, and the availability is always available. And also, we have a new domestic air water cleaning application. You see that now very common. Everyone has an air purifier at home, and water cleaning system as well, probably. So this is something that we'll see how it's going to be developed after the pandemic. And we already, I think that a lot of people already have stored some of these rapid test kits to test themselves, to make your family safe, or probably to make your friends or the colleagues safe. And so this is something we'll see whether this technology will be continuing for other things like flu or whatever in the future. As I said that we'll continue to develop new vaccine via mRNA technology, and also we already have drugs for COVID-19, but probably we have drugs for other viruses like flu as well. And we have much shorter drug development cycle, as that explained by Professor Dunn as well. And also we also advanced the hospital ward design to support the patient, to support the patient, but also to protect the hospital nurse and staff, which they actually sacrifice a lot to help people, and we should also concern them as well. So it creates a long-term impact on the healthcare system, because we'll see that all this system is not only for conflict, because health is related to everything. And one of our biggest challenges we know is about aging population. And you see that the impact of COVID-19 is hitting mostly to the elderly people, because who go to the ICU, who need all this hospital healthcare are those elderly people. But then this might also advance in the future, not only to the COVID-19, because old people, they have a range of diseases like cardiovascular disease, cancer, diabetes, infection, and all these, that what we prepare or we developed today could be benefit in the future for those people. One day we are going to get old, and to prepare for ourselves, I have to say it, that we are benefits from this cost efficiency, and hopefully that those people we have to face in the future. You see this diagram, actually we cannot avoid that people live longer life, and so that to get prepared for our future. And so what BME, what we are doing here is that we're trying to support new instrumentation and also non-human aspect of the healthcare system. We see that, we provide a lot of different tools, new tools from prevention, protection, and treatment. And so we are working on the value chain via our innovation, design, material, manufacturing, so on and so forth. And we need expertise from, different disciplinary, like from engineering, from nurse, doctor, hospital, but also like all this telecommunication. We need to work with some IT person, on data analysis and so on and so forth. So it's really like a very interesting and multidisciplinary area that has unlimited opportunities for us. So that's, I finished my talk, and thank you everyone for listening, and I will pass it back to Professor Ho then. Thank you.
Thank you, Professor Don and Professor Mark. Now we're going to actually move on to the next part of the seminar. I've been told that both of our student ambassadors have prepared their sharing speech. So may I invite first Boris Leung. Boris is actually our fourth year student, and he wants to share his experience with you. So I'm going to hand over to Boris, and then followed by Patrick C, year 3.
Hello, I'm Boris, and as mentioned, I'm a year 4 student, and I'm actually have studied a lot of course in this BME. And if you really, let me ask you a question first. If you are really interested in medical area, so maybe you can ask yourself, what can you contribute to the medical area? For me, before I go into the BME, there is no COVID, and I just want to contribute to the medical sector. And after going into the BME in my second year, and the COVID pandemic begins, and then my question become more clear is that what can I contribute to the COVID? And then I follow Professor Aaron and do research in his lab. And currently, my project is doing about the PCR project. I think that it's very important for us to have a thought of how to contribute, so that we can study, because the course university stuff is not easy, and it requires some hard work. And if you don't have a motivation, it is very hard for us to overcome it. So therefore, before you go into the BME, so you have to ask yourself first, what can you contribute to the medical area? And let me talk about the course I've studied in BME. In the first year is about some basic science subject and mathematics lessons, and some basic concept of BME. For example, how is this machine working? Some very basic principle. And then in the second year, we have to study about some human structure, the structure of humans, so that we can have better understanding on how the machine work. And in the third year, and we have to do many projects, and we have to really solve a real life problem in our course. And there are many projects in BME course. For example, some telemedicine course, and it's about writing an app with some medical device. And in my final year is that's currently I'm studying. The most important thing in the final year is about the final year project, and you have to make a decision on what area you're really contributing, and you are doing a project to contribute to the problem. Yes, and I believe that BME really helped me a lot in my studies. And for example, BME offered me a lot of research opportunities, so that I can understand that what area I'm going to do in the future, and also I understand that what I'm strong at and my weaknesses. So I believe that BME is a very good program. Thank you.
Thank you, Boris. Now I'm going to invite Patrick C to share his experience as a third-year student.
Yes. Hi, good morning, everyone. I'm Patrick, a year 3 BME student. After the sharing of professors and Boris, you might get some basic concept of biomedical engineering. You may wonder how is the study in CUHK BME and why I choose BME. So I would like to share my CUHK life to you. The reason I choose BME is because I believe that it is the only subject which links biology and engineering. The wide range of subjects covered by BME makes me build in-depth understanding to use engineering prospect to solve medical and biological problems. Actually, BME problems is anywhere. COVID-19 is already an example. For another example, I'm working in Hong Kong Adventist Hospital as a part-time biomedical trainee technician now. So we actually manage and perform maintenance procedures of medical devices. By studying biomedical engineering, you will learn many about medical devices like their regulation, their operation principle, etc. So are you interested in making a difference and improve the lives of millions of people? As a biomedical engineer, you are given the incredible opportunity to create life-changing and even life-saving machines. If you are interested in it, I really recommend you to choose biomedical engineering. However, if you are not interested in medical devices, it is totally fine. It is because BME is quite wide that you can take different stream preferences. In CUHK BME, we learn biomedical electronics, biomechanical, biomaterials, medical imaging, and of course, some basic anatomy and physiology. Therefore, the career of BME is also not so limited. Biomedical engineering students can be employed in hospitals, research facilities, government agencies, universities, and many more. This field is still evolving, I think, and you'll never know what sorts of doors will be opened when you graduate. After talking much in BME, maybe I can share some interesting experiences of my university life. Upon my 3 years of CUHK studying, I found that CUHK provides many chances for me to explore and expose myself. The studying environment is good, of course. CUHK provides many opportunities for me to go exchange, to find internship, and also scholarships. Instead of the field of academic, the extracurricular activities also enrich me a lot. For me, I participated in the Biomedical Engineering Society for 2 years. In the society, I found many people who are enthusiastic about the same thing as me, like we are all willing to organize some activities for other students to gather all students. The numerous activities and people from many different cultures provides me a great opportunity to try something new. Maybe you discover some secret talents that you had not previously unlocked in your university life. I wish to see you in CUHK. Thank you.
Thank you, Patrick. Thank you, Boris, also for sharing your experience with us. Now, time is actually ticking fast. We are only given 1 hour of time window to do this seminar. Now, I watched the clock and we have about just over 15 minutes left. And it's going to be an open forum. So now everybody participates. Now we have 3 professors from the department and 2 student ambassadors here. And please send in your questions, or you either ask them live through the microphone, or you just type in your message, and then we will just address your questions accordingly. Okay, so time is for everybody now. Usually it's like that. We need some time to warm up. Anybody ask any questions? No?
Maybe I can invite some people to share. Maybe let me ask you a question. What is your expectation to the CUHK BME? So if anybody is willing to answer, feel free. Thank you.
Thank you, Boris. What is the expectation? Okay, so I have one question. Is BME related to technology as well? Well, one of you actually sent in a question asking, is BME related to technology as well? Yes, it's 100% related to technology. In fact, a big part of the curriculum is to address technology aspects. I mean, as Patrick has shared very accurately, that it's bridging the gap between health sciences and engineering. It basically provides solutions to solve healthcare problems through technology, through the application of science information. Okay, so also try to address Boris' question as well. What do you expect to get from BME, CHK? So another question. So may I ask, will we learn about something related to programming? Yes. Yes, during the 4 years of BME course, there are many opportunities to learn about programming. First, all engineering students have to go through a course called Solving Problems by Programming. And second, in year 2, there is a project course. Half of it is actually to use Arduino to write microcontroller programs to turn it into an instrument for solving medical problems. For example, the blood oxygen detection, and then nucleic acid amplification, eye detection, and then also biosensing. So we train students to actually program a microcontroller to do those work.
Maybe I can add something on that. In the BME course, there are some other some courses concerning about bioinformatics, and there are lots of programming in that course. In those courses, for example, in a course called Personal Genomics, we have to learn how to write Python, and using Python to write some AI for our project, because that course we have to address our own personal genomics problem, and then we have to use Python to write it. And for other courses like neuroengineering, we have to learn how to use MATLAB to use some manipulate some ECG data so as to obtain our useful information. For example, you can just use a hair clip, and then you can know whether the patient is eye opening or eye closing. Yes.
I see. Yeah. So there is many other programming opportunities as well. Now, I've just received 3 more questions on the list. The first one is, what is the expected score to get into the course? So I think you're talking about HKDSE. Our median score over the past 3-4 years is 25. Best 5 is 25. Okay, so that's a sort of kind of threshold we're looking at. Okay, so we actually give strong weighting to science and maths courses and English as well. So what are the major differences between BME courses between different universities, for example, Hong Kong U and CUHK and CTU? Well, the Hong Kong U one is more mechanical engineering oriented, bioengineering oriented. The CHK one is more instrumentation oriented. So we are more diverse in a way. We have only several courses dealing with the material mechanics aspect of it, and then we have other courses that are more into the instrumentation and sensing and nanotechnology aspects, so it's more diverse. And then the fact that Hong Kong U and CHK have medical school has given us a much better advantage, because we have direct interrelationship and collaboration with medical school professors. And another important aspect of the CUHK BME is that a good proportion of our courses are actually taught by professors from medical school. I mean, if you notice, in fact, our department is quite small. We only have about just over 10 professors in the department because, you know, many of our courses are taught by faculty members from other departments, including medical school and biological sciences. And then, do we have to be good in physics to study BME? Yes, we have to be good in fact, equal distribution, physics, chemistry, biology, and mathematics. All four domains are equally important, but it's very difficult nowadays to find students who are good in all those four aspects. So what we do is, in fact, for students who are actually not as well prepared for a certain science subject, for example, physics, then they come in, we send them to a course in physics in the university curriculum. If somebody who's not good in chemistry, then he'll do the same. Somebody not good in biology to do the same, math, so on, okay? I'm not very interested in technology and programming. Is it still for me to do BME? Well, this question, not interested in technology and programming, is it still suitable for me to study BME? I think instead of me answering that question, I should leave it to Professor Dawn, because Professor Dawn actually comes from a different background. I mean, she might be in a better position to answer that question.
Yeah, I think my background is not really in engineering, so all my training, either bachelor degree, undergrad training or postgraduate training, are all in chemistry or material engineering. But or material science. But I feel technologies related to biology, to the healthcare, is more intriguing and more impactful. So I gradually divert my own interest and then focus towards biomedical engineering. So the thing I believe is that the backgrounds doesn't really matter. So there's an old saying, so your starting point doesn't determine your future directions. So that's what I believe. So if you are passionate about the topic and then you have motivation about it, I think you will be good, can do good.
Yeah, I noticed that Professor Mark also has something to add.
Yes, I have to agree, because actually I'm not also starting with engineering background. I share some similar background like Professor Dun. I'm a chemist as well. And so we start with science, but then as long as you start with science, but then you start to gain knowledge. And then in one day, you think about how you want to implement your knowledge to do something else. And then this starting point of like how you translate science into something useful. And this part is like so-called technology. So I think that, the BME program also has a lot of things to inspire you, that you can actually get use of what you learned in the past from science. And then through this experience, you will find out a solution, as I said that. But I mean, as I said that, Professor Ho said, we are trying to provide a solution to support the medical science. And in order to build this solution, you need to have knowledge and all this scientific knowledge. So this is something that is not really important, as from my experience, that you have to design right now that you are suitable or not. But then, as I said, that you need to you just learned, and then you'll find your way out at the end. This is what I want to share with you as well.
Yeah, I mean, just to add, I mean, between our three professors here, I come from engineering backgrounds. I design and develop new instruments, devices for solving medical problems. Whereas Professor Don, she actually works on engineering of genetic molecules to solve healthcare problems. So Professor Don actually works on genetics and biochemistry all the time, right? Similarly, Professor Mark also works on the development of proteins, functionalization of a surface for detection of antigen antibodies, i.e. biosensors. A lot of it is actually biochemistry oriented and molecular engineering oriented, right? Yeah.
Yes, you're right.
Yeah.
And then
So-
we try to imply those knowledge, and then now we build instrument, and we build many different biosensors nowadays, and to support the, you know, the doctors and the healthcare system. You're
So
right.
the field of healthcare, biomedical engineering is very broad. I must say it's very broad. And that's the reason why at the beginning, both chemistry, physics, biology, and mathematics are important. In fact, relatively less important is programming, because you can learn programming yourself, whereas science, you have to go through the formal training in the university. Now, let me go back to another question. It's actually for student ambassadors to answer, okay? If I study biology and chemistry in Chinese in my secondary school, okay, is it difficulty? Is there any difficulty? What do you think?
I think if you study biology in Chinese in your secondary school, it will be quite difficult for you to follow the first year subjects. However, I have some friends who also study biology in Chinese, but if they work hard, I see they also can get some good grades in the course. For the chemistry part, it is the same, but I think in year one, we do not have much courses related to chemistry, maybe 1 or 2. So you still have time to get back the information. And I think it is okay.
Yes, also there is an enhancement course in Saturday, which is also about biology. If you have any question concerning the course or the course material, you can ask there, and there are some senior student who is very professional in biology, and they can give you some advice.
Well, in a nutshell, university education is all about self-learning. If you find yourself weak in certain aspect, you put effort, put time into it. I mean, language cannot be a barrier, because at the end of the day, the essence of science is the fundamental theory itself, not the language. So what I wanted to say is, in fact, you may find it difficult, but if you put in effort, you'll overcome it quite easily. I mean, just like what our students have experienced before. Now, and there is, our administration actually has posted a website. Okay, you can actually click into the website to actually have an overview of our DSE admitted student score. I mean, that will give you a more accurate sort of overview of everything. Okay. Now, so may I ask about BME, studying BME? Usually study in lab or developing technology with a computer more? I think it's a bit of everything, right? I mean, I noticed that Professor Don is not showing signs of agreeing. I think it's a bit of everything.
And then because BME in the year 3 and year 4, we have 4 different directions for you to choose, so you can dive more. So some directions, I believe, is more a lab hands-on experiments. So mostly students will do a lot of experiments in the lab physically. And then some directions, they will more focus on the computer side, do some simulation, do some data analysis. Yeah, so it really depends on which direction, which stream you want to choose in the last 2 years of your study.
Yeah, I think to give you a better picture, I mean, 123 credit units is the requirement to graduate. About 1/3 of it is required courses, which cover everything, you know, computer, labs, and everything. And then another 1/3 is your options. So you can choose options that are more lab-based. I know that Professor Don runs a 100% lab-based course, okay? And so there are other courses that are 100% programming. So you pick your choices and so on. Now, there's one last question which I want to answer earlier on. It's actually whether there is opportunity to develop new kinds of software or machines in the BME courses. Yes, I mean, you have 4 years with us. I mean, 4 years meaning 48 months, okay? The department only provides a platform for students to acquire knowledge. If your your interest is to develop and explore new software and new machines for the healthcare sector, then we'll just help you. You just knock on the professor's door, and then we'll try and give you opportunity to work in the lab, and then we'll try and give you guidance to explore your interest. Don't forget, you've got 48 months in the department for you to explore your interest. That's most important, because at the end of the day, we are helping you to be a lifelong learner. Right.
Yes, maybe I can add something in this question. I also interest in software engineering, so I took a course called, its title is exactly software engineering. It is offered in CUHK, as we have to take 123 units. This just stated by Professor Aaron Ho. So you are free to choose some free electives, like you may study other course in maybe in other department or maybe other engineering prospect. So it is quite free, but the most important thing is that you should find your way to build some intuitive solution to BME.
Yeah, indeed. Thank you so much, Patrick. I mean, your experience, spot on. It's for you to explore. I mean, it's roughly 1/3 fundamental, 1/3 compulsory BME senior courses, and then 1/3 optional electives. So you can use that 1/3 of units for your own, development. Now, there's another question: internship. Yes, students are encouraged to embark on internship, either just summer internship in hospitals or even in departments, or 1 year of sort of year break to work in the company. Okay, so and you get a salary out of it. So again, the department is a platform to train students, and internship is one very important aspect for students to acquire knowledge. Yeah, I mean already answered your question, Vita. Thank you. Right, so time is actually running short, and we already sort of overshot the 1 hour mark. And think the university actually is very strict about timetable. Now, I would like to sort of invite students who are you're ready to leave the meeting if you want, and we'll stay on for a little while in case you have other questions you want us to answer. And then thank you very much. So all the best to your HKDSE, and hopefully we see each other in the department after the summer. So thank you very much. So those who have more questions, you can stay on, and then we'll just try our best to answer your questions. Thank you. Bye-bye.
Thank you. Goodbye.